In 1997, Garry Kasparov was beaten by IBM's Watson in chess. Following this event, he invented Centaur chess, or advanced chess. In Centaur chess, a human plays together with a machine. We want to adopt the concept of a human playing together with a machine for design. Through designing together with a machine, designers and machine can work together to develop and conceptualize ideas for the 21st century.
When we initially thought about Code 3100, we thought about how to introduce students on the co-integration between biomimicry, design, and computer science. We wanted the students to learn on abstracting natural principles and transforming them in technologies that could be sustainable and could give a life to architecture. We think that architecture is still at a stage in which it is a little bit static and not completely resilient to the environment. And so that's why we thought, okay, let's start with biomimicry, selecting a biological role model and understanding how a mechanical kinetic structure can be developed from these. Students were a little bit confused initially, but they are really enjoying now the process. And with the first presentation, we saw a really good improvement from them. What we hope we are going to achieve is a preliminary design package in which we have a project that has a top-down approach with a mechanism, a kinetic structure, and material system exploration, and at the same time a top-down approach of an overall shape that changes through different stages in time. It could be throughout a day, a week, or a month. And it's through a machine learning algorithm that we are going to predict how this shape is going to change depending on the data set that could be environmental, human, or of any other nature. The good thing of the course is that the students are experimenting on material systems and advanced fabrication technologies. So they are exploring different material systems, and they are all related to the biological role model that they selected and the mechanism that they abstracted from nature. At the same time, another interesting thing is that the package that they produce at the end of this course is going to be used by different students in different years of computational design program at UNSW. So a complete set of new ideas and input is going to be given to the project, and the project is going to be built in different environments. It could be at ARUP Sydney, ARUP Melbourne, globally, or anywhere else, maybe on Mars. Having ARUP involved is a really good opportunity for the students, and vice versa. Because students are third-year students of a Bachelor in Computational Design, they're obviously quite new to the professional environment and to the industry. And so participating constantly or progressively to the interaction with the professionals is a way of learning about the industry, but at the same time seeing the process and absorbing information from people that obviously have more experience than them. So they are going to interact with structural engineers, material system engineers, research experts, and they are going to take a lot out of this. But at the same time, students have a completely new way of looking at things, and that's true for every student in every year. They can actually teach new tools, innovative approaches that they absorb every day at the university in such a vibrant environment, and they can transmit them to or transfer them to ARUP and other professionals in the industry, which gives a completely new point of view to project for clients. And so when ARUP decides to present this project or this methodology or this approach to clients, they can say, this is completely new. No one has ever thought about this before.